General requirements of remote terminal units, RTUs. Overview: remote terminal units, RTUs, form the core controllers and data acquisition interface to field instrumentation in the station control system. They interface with both discrete and third-party systems, including emergency shutdown, ESD, and fire and gas, FNG systems, as well as integrating with top-end SCADA systems. The RTUs are designed to ensure seamless data acquisition and control across various stations. Configuration: RTUs are self-contained units capable of collecting and processing data from intelligent devices through Ethernet and serial interfaces. They support integration with third-party systems via dry contacts, current or voltage signals, and contact-making pulsing devices. Key features include no false outputs during power-up or down, a minimum of 256 unique RTU addresses, selection interlock to prevent more than one control selection at a time, remote downloading of configurations and software, remote diagnostic capabilities. Programming: RTU programming involves the use of a Windows-based interface for system configuration, logic programming, and database editing. This interface supports drag-and-drop features for function blocks, password-protected access control, data import-export in ASCII, Excel, and Access formats, online and offline modifications without system disruption, ladder logic, text, and function block formats compliant with IEC 61131-3. Logic capability: RTUs support extensive logic capabilities, including mapping I/O data to a local register array with at least 20 48 16-bit registers, a variety of logic input and output conditions, advanced math and logic operations, timer functions and function blocks for advanced control operations. Data logging: RTUs feature robust data logging capabilities, with event log entries time-tagged with 1 millisecond resolution. They can store up to 50,000 event logs and allow retrieval based on various criteria such as date time, priority, and user type. Communications interface: RTUs communicate peer-to-peer over 10/100 Ethernet and integrate with ESD, FNG, VSD drive controllers, UCP LCPs, MCC, and third-party systems. They generate system alarms in case of communication failures or overloads. Power supply and grounding: RTU power supplies accept both AC and DC inputs and are designed to support RTU operation under various conditions. They provide advanced power management, including monitoring of status and analog values, control of outputs, and LED indications for various statuses. The power supply includes inputs for AC, 90 to 260 volt AC, and DC, 20 to 60 volt DC, with outputs for load capacity, battery charging, and auxiliary power. Environmental conditions: RTUs are designed to operate in a temperature range of -20 degrees Celsius to +60 degrees Celsius and are suitable for storage from -20 degrees Celsius to +80 degrees Celsius. They meet local requirements for noise immunity and emissions. Security: RTUs have two types of security: programming and configuration interface security with multiple user access levels. Configurable access levels for each RTU communication port to control read and write access. Diagnostics: RTUs provide detailed diagnostics for local and remote interrogation, including health presence of each RTU module, state value of each I/O channel, system diagnostics and communication statistics. I/O hardware specifications: RTU I/O hardware specifications include analog input modules with isolated inputs, high resolution, and accuracy. Analog output modules with isolated loop power and high accuracy. Digital input modules with wide-ranging inputs, high-speed counting, and SOE recording. Digital output modules with high contact ratings and external relay boards for higher-rated contacts. These general requirements ensure that RTUs within the station control system are capable of reliable and efficient operation, providing essential control and data acquisition functionalities. RTU configuration: features and capabilities. 1. Self-contained units. RTUs are designed to be self-contained, capable of collecting and processing data from intelligent devices such as ESD PLCs and VSD systems through Ethernet and serial interfaces. They also interface with third-party systems like metering systems via dry contacts, current or voltage signals, and contact-making pulsing devices. 2. Power management. RTUs ensure no false outputs occur during power up or power down and support a minimum of 256 unique RTU addresses. Selection interlock features prohibit more than one control selection at a time. 3. Remote operations. RTUs allow for remote downloading of configurations, parameter changes, and application software. They also support remote diagnostic capabilities from central control rooms. 4. No single point of failure. The design ensures that no single component logic failure results in a false output operation. Failure of the first component, in conjunction with a second component failure that could cause a false command, must be detectable during normal RTU operation. Programming interface. 1. User-friendly interface. Programming, configuration, and database editing are performed using a Windows-based interface. This interface supports drag-and-drop features for standard function blocks and other Windows system features for data selection and editing. 2. Access control. All configuration, logic programming, and data entry functions are password protected, with appropriate access control methods ensuring security. 3. Support for IEC 61131-3. The programming system allows for logic editing in formats compliant with IEC 611313 standards, including ladder logic, text, and function block formats. 4. Online and offline programming. Modifications can be made both online and offline without disrupting the system's operation. Changes are stored permanently and not lost during an RTU reboot. Data import and export. 1. Flexible data handling. The system supports data import-export functions, allowing the database or subsets of it to be exported to files in plain ASCII format, Microsoft Excel, and Microsoft Access formats. Similarly, data can be imported from these formats to facilitate large-scale data changes. 2. Function blocks and code library. The system supports the use and editing of function blocks, allowing for a central code library that can be updated globally if the function blocks in the library are modified. Monitoring and diagnostics. 1. Real-time monitoring. Engineers can monitor and set the status of all inputs, outputs, timers, counters, and coils. They can also disable and force inputs, outputs, and coils to simulate system operations. 2. Search and trace functions. The programming device provides a search and trace function to locate elements and their program locations, indicating power flow through all elements. 3. System diagnostics. Detailed system diagnostics, including machine status information such as error indication and memory usage, are available on the screen. The system can compare versions of programmed ladder logic with the program executing in memory and provide a summary of differences. 4. Program loader. The system supports the use of a handheld program loader for minor software modifications and software packages that can run on IBM-compatible personal computers running Microsoft Windows 2000 XP. Security 1. User access levels. The programming and configuration interface supports multiple user access levels configured by a system administrator, ensuring restricted access based on user roles. 2. Port security. Each RTU communication port has a configurable access level to control read and write access. 3. Diagnostic capabilities. The RTU includes advanced diagnostic capabilities for I/O modules, the processor module, and general RTU operations, accessible both locally and remotely. 4. Insulation and isolation. RTUs meet specific insulation and isolation standards, including power frequency withstand tests, insulation resistance, and high-frequency disturbance tests, ensuring robust protection against electrical transients. These detailed configurations ensure that RTUs in the station control system are reliable, secure, and capable of handling complex data acquisition and control tasks. RTU programming. User interface. Windows-based interface. The RTU system configuration, logic programming, and database editing are performed using a Windows-based user interface. This interface allows for programming, monitoring, searching, and editing to be accomplished with a dedicated workstation that remains permanently connected to the RTU. These functions can be carried out while the controller is either offline or online. 2. Look and feel. The interface follows the general style of typical Windows-based application programs, utilizing features such as drop-down lists, drag-and-drop functionality for standard function blocks, and other Windows system features for data selection and editing. All configuration, logic programming, and data entry functions are password protected, ensuring appropriate access control. Data import-export 1. Flexible data handling. The system supports data import-export functions, enabling the database or a selective subset of it to be exported to files in plain ASCII format, Microsoft Excel, and Microsoft Access formats. Similarly, data can be imported from these formats, facilitating large-scale data changes. Logic Programming 1. IEC 61131-3 Compliance. The format displays program functions using functions based on IEC 61131-3. The logic editor supports the use, creation, and editing of function blocks and allows for a central code library. Applications using function blocks from this library can be updated globally if the function blocks are modified in the library. Monitoring and simulation. Engineers can monitor and set the status of all inputs, outputs, timers, counters, and coils, as well as the contents of all registers in decimal and hexadecimal formats. The system also supports the disabling and forcing of all inputs, outputs, and coils to simulate system operations through the engineering workstation. 3. Search and trace functions. The programming device includes a search and trace function to locate any element and its program locations, indicating power flow through all elements. It also provides machine status information such as error indications and memory usage on the screen. 4. Version comparison. The system can compare versions of the programmed ladder logic with the program executing in memory and provide a summary printout of differences. Preferred programming tools. 1. Handheld program loader. A handheld program loader capable of minor software modifications is preferred. 2. Software packages. Programming software packages for the RTU should be able to run on an IBM-compatible personal computer operating on Microsoft Windows 2000 XP. 3. Programming capabilities. It should be possible to program in ladder logic, text, as well as drag and drop function block formats and other formats supported by IEC 61131. Additionally, users should be able to enter program titles, comments, and I/O lists, and modify programs both offline and online, with changes stored permanently and not lost during an RTU reboot. RTU logic capability. Local register array, storage formats. The RTU should support mapping I/O data to a local register array with at least 248 16-bit registers. These registers should support the storage of various data formats, including 16 bits of digital I/O status, 16-bit unsigned integer, 16-bit signed integer, 32-bit long, 32-bit floating point, IEEE format. Ladder logic input conditions. The RTU logic editor shall include the following ladder logic input capabilities as a minimum. Contact conditions, normally open, normally closed, set, reset, comparison conditions, less than or equal to, not equal to, greater than or equal, logical masks, or, and, nor, NAND, edge trigger, positive edge, negative edge, change of state, contents. Timer functions, periodic, on delay, off delay. Ladder logic output conditions, coil operations, normal, negated, set, reset, copy. Data operations, single, block, string, multi. Mathematical operations, basic math functions, increment, decrement, add, subtract, multiply, divide, remainder, square root, exponential, logarithm, sine, cosine, tangent, BCD to binary, binary to BCD. Logical operations, logic functions, invert, and, or, NAND, NOR, XOR, RUL, rotate left, ROR, rotate right. For function blocks, control and program flow, call, return, program, jump, end, advanced control functions, PID blocks, calculation blocks, global or individual RTU clock synchronization, report printing, video monitoring capture functions. Communication functions, transmission functions, TX data, TX ASCII, alphanumeric and SMS pager messages, other communication drivers, reception functions, RX data, RX ASCII, other communication drivers. These detailed logic capabilities ensure that RTUs are equipped to handle complex control and data acquisition tasks efficiently and reliably. RTU data logging. The RTU, Remote Terminal Unit, in the station control system has robust data logging capabilities designed to record and store critical data efficiently. Here are the key features and requirements for RTU data logging. Data logging capability. The RTU shall log any I/O or register data value. Each event log entry must be time-tagged with a resolution of 1 millisecond. Parameters included in each log entry: year, month, day, hour, minute, second, millisecond, RTU ID, data priority, data user type 031, data value 2 bytes. Next, event log capacity. The event log capacity must be configurable in the RTU memory setup. A minimum of 50,000 event logs should be supported before any data is overwritten. Data retrieval. The RTU logic must allow storage of logs using the data priority field to mark the priority of the data to the master. Event logs should be retrievable based on the following arguments: date time, priority, user type, RTU data ID. These features ensure that the RTU can handle extensive data logging requirements, providing detailed and timely information crucial for system monitoring and control zero source. Analog input requirements. The analog input AI requirements for RTUs are designed to ensure accurate and reliable data acquisition from various sensors and instruments. Below are the key specifications and features. Input wiring. Individually isolated inputs. Hardwired analog inputs should be connected to the RTU through individually isolated inputs rather than input multiplexers. This ensures better isolation and reduces the risk of cross-interference. TASH AD converter specifications. Resolution. The analog to digital AD converters must have a resolution of at least 14 bits, 15 plus 1 sign bit. Input types. RTD inputs. Resistance temperature detector inputs for accurate temperature measurements. 4 to 20 milliamp differential isolated input. High-level current inputs. 0 to 8 VDC differential isolated input. High-level voltage inputs. Thermocouple inputs. Low-level voltage inputs with cold junction reference. Electrical characteristics. Input impedance greater than 250 ohms. Noise rejection. Common mode noise rejection ratio 80 dB or more. Differential mode noise rejection 85 dB at 50 Hz. Accuracy 0.1% or better from 0 to 50 Hz and over the full range of the power supply. Signal conditioning. Linearization. The RTU should provide linearization of standard thermocouple signals. Signal conversion. 4 to 20 milliampere signals should be converted to 1 to 5 volt DC at the input terminals using a conditioning resistor that maintains an accuracy of at least 0.1%. Range handling. Under-over-range conditions. If the AD operates in under-range or over-range conditions, for samples less than the minimum values specified, the RTU should report 0%. And for samples greater than the maximum values specified, the RTU should report 100%. Update rate. Analog input module update rate. The update rate for all hardwired analog input modules must be no worse than 2 milliseconds for all channels. Communication protocol. Report by exception, RBE. All analog inputs should follow the report by exception protocol to minimize network polling and reduce network bandwidth usage. The percentage change in value that triggers reporting should be user configurable. These requirements ensure that RTUs can handle a wide range of analog signals with high accuracy and reliability, making them suitable for various industrial applications. Analog output requirements. Connection and specifications. Output connections. The analog output modules must allow connection of at least 4 outputs from a multi-channel digital to analog converter. Resolution. The DAC should have a minimum resolution of 12 bits. Accuracy. The overall accuracy must be at least 0.1% of full scale. Output range. The output should range from 0.4 to 20 milliamps, capable of driving a load of up to 850 ohms. Update rate. The update rate of the analog module should be no worse than 250 milliseconds for all channels. Power and isolation. Loop power. The analog output module should provide isolated 24-volt DC loop power for each output channel. Isolation. Ensure that each output channel is isolated to prevent interference and ensure accurate signal transmission. These requirements ensure the reliability and precision of the analog outputs, making them suitable for a wide range of industrial applications. Digital input requirements. Input module specifications. Connection. The digital input modules must allow connection of at least 16 inputs. Configurable features. Frequency pulse quadrature counting. Sequence of events SOE recording. Electrical characteristics. Wide-ranging inputs. AC 18 to 250 volts. DC 12 to 108 volt. High-speed counting. At least 4 input channels capable of high-speed counting, up to 10 kHz. Low-speed counting, all input channels capable of low-speed counting, up to 1 kHz. Frequency measurement, all input channels capable of frequency measurement to 1 Hz resolution. Quadrature counting, any pair of inputs capable of quadrature counting. Event recording and filtering. SOE recording, on any input channel to 1 millisecond resolution, sufficient memory capacity on the input module to store at least 1,000 SOE records. Debounce filtering, configurable debounce filtering, filter time constant of 1 millisecond, 250 milliseconds for all any input channels. Logical channel inversion, configurable logical channel inversion for all any input channels. Visual indication, LED indicators. Visual indication by means of LEDs provided for each input to indicate the condition of all hardwired digital inputs. A lit LED shall indicate that the external contact is closed. Serially linked digital input signals shall be monitored directly from the operator workstations. Noise and isolation. Noise isolation. Each digital input shall be isolated from high electrical noise. Proper filtering for contact bounce such that contact transitions must last for a minimum of time before a change is reported. The time of the change is at the initial contact. Interrogation voltage. The RTU shall provide a 24-volt DC interrogation voltage as a standard for the status of all hardwired input contacts. Protocol. All digital inputs shall follow the report by exception (RBE) protocol to minimize network polling, thereby reducing network traffic. These requirements ensure that the digital input modules are capable of handling a variety of input types and conditions with high accuracy and reliability, suitable for industrial applications. Digital output requirements, connection and configuration. Output modules. Digital output modules must support the connection of at least 8 or 16 outputs. 8-channel modules. Each output channel should provide both normally open NO and normally closed NC contact pairs with no more than 2 channels sharing a common. 16-channel modules. Each output should provide NO contacts with no more than 8 channels sharing a common. Contact rating. Each output should have a contact rating of at least 2 ETs. External relay boards. Relay board connection. The RTU must be capable of connecting to an external DIN rail-mounted relay board with screwed terminals for field wiring and connection for 16 onboard relays. High-rated relay contacts. These relay boards should support switching up to 16A at 250 DC, 16A at 30 volt DC. These requirements ensure that the digital output modules are versatile and capable of handling a range of output configurations and power requirements, providing robust control capabilities for various industrial applications. Control output requirements. The control outputs, both analog and digital, of the RTU must process the control selections and commands from central control rooms. Here are the detailed requirements. Command processing. Central control commands. The RTU must process control selections and commands received from central control rooms. Protocol compliance. Commands exchanged between control centers must follow the protocols specified in the control philosophy document. Select before operate, SBO procedure. 2 full transaction requirement. All control outputs, both hardwired and serially linked commands, must follow the select before operate SBO procedure, requiring 2 full transactions for a control output to occur. This ensures that no single corrupted message can cause a false command. SBO configurations. 1 selection. Select the output point for control by setting its select signal. The RTU updates the select signal and sets the feedback signal, which is then updated to the control system. Execution. Once the control system receives both select and feedback signals, the operator can give an execute command. This sends a message to the RTU to execute the selected output, resetting the select, feedback, and execute signals. 3 cancellation. Alternatively, the operator can reset the select signal to cancel the operation, restoring all other signals to their original state. SBO system feature. The SBO feature must be a standard system feature to ensure that no 2 points of operation can select and execute a single output simultaneously. Once an output is selected and feedback is received from the RTU, that output is locked out from access by other requests. Protocol application, i.e. interfacing. All intelligent electronic devices, IEDs, interfaced with the RTUs via serial communication links must also follow the SBO protocol. These requirements ensure secure and reliable control output processing, preventing unauthorized or erroneous operations, and maintaining system integrity. RTU diagnostics. Diagnostic capabilities. Local and remote interrogation. The RTU shall have inbuilt diagnostics that allow both local and remote interrogation of diagnostic information. This ensures that users can access diagnostic data from various locations. Basic diagnostic information, presented to the user via module LEDs. This includes fundamental status indicators that provide quick visual feedback on the health and operation of the RTU. Advanced diagnostic information, accessible via the RTU Programming and Configuration Interface program. This includes detailed diagnostics for I/O modules, such as health presence of each RTU module, current state value of each I/O channel, including power supply I/O data. Processor module diagnostics, scan rate, information on the scan rate of I/O and logic, providing insight into the processing speed and efficiency. Current time and date, ensures synchronization and accurate timestamping of events and data. RTU firmware version, identification of the firmware version in use, essential for troubleshooting and updates. Firmware options, details on protocols and application extensions in use. Error status flags, comprehensive list of error status flags aiding in the identification and resolution of issues. Communication diagnostics, statistics, accessible for each RTU in the network, including number of message successes, number of message failures, failures since the last success, port monitoring, capability for local and remote capture of data packet messages to from any RTU port. These messages can be displayed in the programming and configuration interface and saved to a text file for later viewing. These diagnostic features ensure that the RTU is capable of detailed monitoring and troubleshooting, enhancing the reliability and maintainability of the systems. RTU power supplies. The RTU power supplies are designed to provide all necessary power to support RTU operations with advanced power management functionality. Here are the key features and requirements. Power supply inputs. AC input, a wide-ranging input of 90 to 260 V 50-60 Hz from a UPS-based power source. DC input, a wide-ranging input of 20 to 60 V DC, nominally 24 V DC, from a solar power-based source. Power supply outputs. Load capacity. The total load capacity should be at least 50 watts. Battery charger. A 13.6 volt DC output capable of supplying up to 3 amps for float charging of standby sealed lead-acid batteries. Auxiliary 12 volts, a 13.6 volt DC output capable of supplying power to external communication devices such as modems and radios. This output should be switchable via RTU logic to allow communication devices to be turned off in power-saving applications. Auxiliary 24 volts optional, a 24 volt DC output capable of supplying up to 300 milliamps of load for external devices. This output could be an optional feature of the RTU, provided via a plug-in DC-DC option board or an external DC-DC converter. Monitoring and control. Monitoring. The power supply must allow monitoring of status and analog values, including input supply failure, low battery voltage, auxiliary 24 volt DC presence, total RTU current consumption, amps, battery charge-discharge current, amps, RTU battery supply voltage, volts, temperature, degrees CF. Control. The power supply must allow control via the RTU logic of auxiliary 12 volt DC on-off, auxiliary 24 volt DC on-off, I/O module loop power on-off. LED indications. The power supply must include LED indications for watchdog OK status, battery charger active, float charge mode, boost charge mode, low battery alarm. These features ensure that the RTU power supplies are capable of providing reliable and efficient power management, suitable for a wide range of industrial applications. RTU security. The RTU Remote Terminal Unit Security System is designed to ensure secure access and control over programming, configuration, and communication ports. Here are the detailed requirements and features. User security for programming and configuration. Interface, access levels. The programming and configuration interface must support at least 6 levels of user access, configurable by a system administrator. 1. Unlimited access. Full read and write access to all RTU parameters, including configuration parameters, local registers, network registers, system registers, hardware, I/O registers, event logs, and logic programs. 2. Read all, write all, except configuration. Read and write access to all RTU parameters except system registers and ladder logic, preventing reconfiguration of the RTU. 3. Read all, limited write access. Read access to all RTU parameters with limited write access to some local registers. 4. Read-only access. Read access to all RTU parameters without write capabilities. 5. Limited read access only. Read access to some local registers without any write capabilities. 6. No access. No read or write access to any RTU parameters, useful only for RTU port configuration. Access control. The user interface program must be protected by access control logon permissions, verified against a user database to authenticate the password and provide the authorized access level. Users can also select a view-only mode. Communication port security. Configurable access levels. Each RTU communication port must have a configurable access level, with the default access level controlling read and write access to that port. For instance, a port with read-only access would allow reading some local data registers, but not writing to them. Useful in applications such as energy delivery, where limited data access is required. These security measures ensure that the RTU system maintains robust protection against unauthorized access and modifications. RTU operating environment. The operating environment specifications for the RTU, remote terminal unit, are crucial to ensure its reliable performance in various conditions. Here are the detailed requirements. Temperature range. Operating temperature. The RTU must be capable of operating over a temperature range of 20 to plus 6 degrees Celsius. Storage temperature. The RTU should be suitable for storage over a temperature range of -20 degrees Celsius to plus 80 degrees Celsius. Noise immunity and emissions. Local requirements compliance. The RTU must meet all relevant local requirements for noise immunity and noise emissions, ensuring that it can operate effectively without interference and within acceptable noise levels. These environmental specifications ensure that the RTU can function reliably in diverse and potentially harsh conditions, maintaining performance and integrity